All right, good afternoon. Thank you all for coming out. My name is Cedric Owens, and I'll be talking about some ways around some common macOS detections using the Swift programming language. So some background information on myself. I'm currently on the Red Team at Box based out of Austin, Texas. Prior to doing Red Team, I come from a largely BlueTeam background, doing incident response, threat hunting, threat detection. And so that's still a part of me that's really near and dear to my heart. I really like working with blue teams, helping validate detections, helping blue teams understand the attacker's mentality, for different approaches, and just integrating with Blue Team in general. I really enjoy that. Also, I know Red Team is very broad and encompasses many different things, but for me personally, post-exploitation is an area of interest of mine. Like, I enjoy the cat and mouse game of evading or trying to evade the latest preventions and defenses. Also, I was an early 80s baby, so I do enjoy things that remind me of the 80s. So you'll see some memes throughout my presentation reflecting that. And Twitter handle @CedOwens, where I'll occasionally post some things there. So what I plan to talk about is I plan to start off talking about the state of the union through my eyes for macOS from an offensive and defensive perspective, common post-exploitation methods that we've seen for macOS up to this point, and the associated detection artifacts. And then why migrate to macOS internals for post-exploitation? Like what benefit will we get from that? How can we do it? And then last, talk about some examples of doing just that using the Swift programming language. So, state of the union, I would say again through my eyes, the latest desktop operating system market share numbers I've seen, Windows was around 77% and Mac was around 14%. So still a huge gap where Windows is leading the way, which is why most of the tactics that we read about and see are Windows focused. However, if you look in your Fortune 500 companies, a lot of household names that are Windows shops and probably will be Windows shops, one thing that I am noticing is that VIP users such as executives or admins with a lot of rights are being segmented over and more and more often over onto Macs. So you look at that and you look over and look at tech companies in the Bay Area, and it's almost a complete opposite, where the vast majority of endpoints are macOS with very little Windows. So I think from an offensive and defensive perspective, it's hugely beneficial to be familiar with macOS. Just because even in a Windows shop is going to be likely at some point you're going to have to either target a macOS device or investigate it, dig into it. So I think that will be useful. In terms of endpoint detection and response products, those have definitely come a long way. The first time I remember getting exposed to EDR from Mac, it was really basically a flat file logging system. The logs were barely normalized. There wasn't much intelligence out of the box that would be useful to a blue team. And so you fast forward a few years now and EDR has gotten better. The logs provide the analysts with most of the stuff that are needed in most EDR products. And there's even some decent out of the box detections. In terms of post-exploitation, what I've seen mostly up to this point have been scripting-based post-exploitation, where the post-exploitation tool itself lives on the command line. And when I say that, basically using a scripting language, such as Python as an example, to access shell commands that the tool uses for post-exploitation. So, speaking generically here, when it comes to detections, most detections have existed in this blue box here, focused on command line and processes being spawned. And the reason being is because most of the post-exploitation tools up to this point have also lived in that blue box. Again, living on the command line through some type of scripting language on the host. So you've got your command line where processes are spawned, which you do various things. And at the end of the day, the process is really just a front end for a back end API call. And so kind of what's happened in the Windows side of the world is kind of what I've been pushing myself to do, is like get off the command line completely, limit the number of processes I create, and bring my own code to invoke API calls directly. So I'm not completely bashing scripting languages at all. Like Python is my favorite by far. And I even wrote my own post-exploitation tool for macOS in Python. But I wrote it from a bit of a different reason. It's called MacShell. And I wrote it, for one, I wanted to get underneath the hood of post-exploitation so I can understand what are the unique challenges with writing your own. What considerations do you need to keep in mind when building your own? But I also wrote it for BlueTeams, where it's very simple. It's just a client and server script. So BlueTeams can easily follow along the logic for how post-exploitation works, how the communication between client and server happens, how an operator controls an endpoint, things of that nature. And so as I wrote it, a couple things stood out to me. I kind of assumed that, with it being 2018, 2019, around when I was writing it, that a lot of the approaches used by this would be detected by most EDR products. But I was pretty surprised to find that was not the case. A lot of the post-exploitation using Python, running command line utilities were still not detected. So I put my BlueTeam hat on, worked with BlueTeam, started analyzing it, and started to find a lot of common patterns that BlueTeams could easily key in on. So some of those patterns include parent-child relationships. So speaking of Python in this example, for post-exploitation, OS libraries like system, popen, commands for Python 2, subprocess for Python 3, they all operate in a similar way when you look at parent-child relationships, where by default you have Python spawning a shell environment, which in this case by default is bin.sh. You could totally change that. But Python spawning shell environment, which then executes the command. Another thing that BlueTeams could easily key in on that I saw as I was analyzing my own tool was a count of network connections from Python. Since in this case, Python is running and makes that initial connection to the server, on the client side, the host you're controlling, Python is just really sitting there waiting for the next command from the server. So you could build some analytics around that and see how Python's beaconing out. Also, command line strings. Again, since tools up to this point have lived on a command line, these are things BlueTeams could easily key in on. So screen capture, -X, that's the native way through the terminal on macOS to get a screenshot. -X tells it to do it quietly without making that camera click sound. Or OSA script. And OSA script is really an engine that allows you to run AppleScript on macOS, which allows for easy automation of simple and complex tasks. So like OSA script with the word pop-up may indicate that there's a user who's getting prompted to enter credentials or click a button or do something. OSA script in clipboard, that may indicate that the user's clipboard contents are being accessed. So those are some common things and examples of traces that BlueTeams could easily key in on when your post-exploitation lives on a command line. And so here's an example from my tool MacShell. One of the operator commands I had was check security. So when the operator enters check security, that command gets sent over to the client that you're controlling. And what happens on the client side is it evaluates that command and converts it to a PS command, where it starts grepping for things like EDR products or antivirus, and then it sends the results back. So the operator knows what AV or EDR products are running. From an EDR perspective, this fits nicely into what was shown on the previous slide, where you have Python spawning bin.sh, which in this case spawns PS to run this command. And so if you step back over time and look at a post-exploitation running, you continue to see the same thing over and over. As Python waits for commands from the server, each time it gets a command from the server, a new bin.sh instance is spawned, which allows the system to in turn operate or execute whatever shell command that the operator is trying to run. So this is typically how, over time, it looks when your post-exploitation lives on a command line. So some pros for scripting-based post-exploitation living on a command line. It's been convenient up to this point. Scripting languages have been on macOS natively, so it's not like you have to install anything. There's less headaches. Like you don't have to worry about gatekeeper. You don't have to worry about digital signatures, notarization, sandboxing, things that will cause an attacker more time and planning. And it may still go undetected in in a lot of environments today that may just not be focusing on macOS. The cons, however, there are blue teams that are used to defending macOS enterprises at that level, and they're familiar with these tactics. And if they see something running on the command line and they have alerting for it, it will burn down a red team operation really quick and early in the process. And it also provides very limited options for macOS. Like there's lots of other things you can do for post-exploitation on macOS beyond just the command line. And so this was something that also really stood out to me, looking at developer notes and how, like I said, up to this point, we being offensive engineers have been able to take advantage of the fact that scripting languages have been on macOS. But going forward, the plans are to remove those going forward. So we'll no longer be able to make that assumption if we're doing a red team operation and planning, we're targeting Mac, that we can use Python because it's going to be there. Yeah, a user can install it themselves, but it's just not a guarantee that the target user base will have it on. So for me, this was a reminder that it's time to start pivoting and trying some different techniques. And so that's what brought me to the next aspect of thinking what's gone on in the Windows world, where you think about batch commands that eventually evolved to PowerShell, which eventually evolved to C#. And over time, just getting away from the command line and starting to invoke API calls. Like, can we do the same thing for macOS? Which will basically allow us to challenge the way we've been doing detections so far. So what I did is I challenged myself. I showed you guys the slide earlier for MacShell, which is the client piece that's running the host you're controlling is in Python. So I challenged myself as a side project to rewrite that over into Swift so that I can then take as many command line based post-exploitation tasks and convert them from the command line over to API calls. So I picked Swift as the language. Objective-C would have been the other option. Objective-C has been around for a while. Swift is pretty new, but I personally like the way Swift is laid out. So I picked Swift. And it gives the same access that Objective-C provides in terms of a lot of the API calls that I would need for post-exploitation, like such as the Cocoa API, which you can do things like anything from screenshots to navigating the file system, and OSA Kit, which you can use to programmatically run JavaScript for automation on your macOS endpoints. But long story short, I picked Swift and started down that road, and it gave me that ability to meet that goal of moving off the command line. So quick steps that I took when setting up, getting started down this road is I downloaded Xcode from the App Store for macOS. It installed the corresponding version of Swift based on whatever version of Xcode you download. I used Playgrounds initially just to get familiar with an idea or a concept or syntax. Once I got comfortable, I then migrated over to projects like an app package or a Mako binary, built the code, and then compiled it and executed it so I have my binary. So once you're inside of Xcode, this is kind of what it looks like when you start a new project. So as you can see here, there's tons of different options of what you can build through Swift or Objective-C. For this talk, I'm focusing on the areas of command line tool option at the top, which I've used to build standalone Mako binaries, or the Cocoa app, which I've used to build app packages for Red Team use as well. But there's tons of other options, and they all allow access where you can use the same powerful API calls. So I mentioned earlier that I challenged myself to convert the Python client over into Swift and get off the command line. So next I'll just show you guys some examples of what the command line argument was and what the code equivalent is when you invoke the API. So first example, my tool MacShell ran the screen capture command and spit out a JPEG of the screenshot. So what that looks like from a code perspective is using the Cocoa API. I also imported a third-party package called Socket so that I could make a socket connection and send the screenshot. But essentially what's happening in the code here is you're enumerating your active displays, you're getting image content for each, and you're storing that in a variable so that then you can like write the screenshot to a file, send it to a server, kind of whatever you want to do with that at that point. Second example, faking, I guess prompting users with fake authentication prompts using OSA script. You feed it on the command line, you feed it these Apple script parameters to say, hey, set this dialog with this message, have a text box, so forth, and so on. So what it looks like in code is, again, with the Cocoa API, is you can build an NSAlert object from the NSAlert class, and then you can manually build the items for that alert that you want the user to see. So you can build your window title, your text. You can add buttons this way. You can add a text box. And then what happens is you capture the user's interaction with that alert. So you capture what text they enter in the box. You capture what buttons they enter, things of that nature. So this is a way to do that same task that's on the command line before programmatically now, which makes detection a little bit harder. Another example is you can invoke the NSAppleScript class and just feed the AppleScript command to that class. So in this example, you're actually still using the AppleScript engine. The previous one I just showed you was just building the alert manually. Here you can still leverage the AppleScript engine without using the OSA script binary on the host. And this is what that code would look like here. Another example, in my MacShell Python tool to navigate the file system, it did things like cd, ls, pwd, to get around on a host. An alternative would be using the Cocoa API. You can leverage the file manager class, which will allow you to do things like get your current directory path, get contents of your directory, change your directory path. And what's neat with this class also is if you're looping through items in a directory, you can check a property called hasDirectoryPath. And if hasDirectoryPath evaluates to true, that lets you know the item you're checking is a subdirectory and everything else is a file. So this is a neat way programmatically to kind of navigate the file system and enumerate files and directories. Next example on the command line, OSA script-E, return to clipboard, gets clipboard contents. And from a code perspective, what you're essentially doing here is working with the NSPasteboard class. And from a clipboard perspective, on the back end, it's basically considered a pasteboard. So you're just getting the string contents of your pasteboard, storing it as a variable where you can send it to another host. So those are examples of getting off the command line and using code. And next, what I'll do is just kind of walk through some examples of how you can build red team focused apps or apps for red team purposes. Again, using code and not having to rely on the command line. So if you're inside of Xcode and you want to build your own app, you select a Cocoa app and you're brought here. And I'll kind of walk through some items on the left. So here's your main storyboard. This is where you design a window that when your app is executed, that the user sees and interacts with. So that's what the main storyboard is. You have on the left appdelegate.swift. That's where you can put code around terminating your app. You've got viewcontroller.swift. That's where you can put code behind your window elements. So if you want the user to click a button and something to happen, you put that code in viewcontroller.swift. And then assets.xcassets, I've used that to add images to your window or set an icon for your app package, things of that nature. So, and then here you just continue to design it till you get it to the point where it's ready for red team use and it entices a user to do something. So let's say you've got that set up. Your next step would you do is you'd have to go through sandboxing to specify what accesses your app needs. Now you could completely turn off sandboxing, but I would recommend keeping it on and just specifying what accesses your app needs. And the reason being is, and we'll talk a few more slides down the road about this, but if you turn off sandboxing, it could affect your ability to get the app notarized, which you may have to do depending on the target OS that you're building for and things of that nature. So I recommend keeping it on. And here's an example of setting your sandbox for a red team app. In this case, we have the sandbox set because in this case we have the app that's connecting to a C2 server. So we want outbound connections enabled. We want the app to be able to access the camera, context, calendar, and then files on the system. So that's pretty easy. You just click capabilities at the top and you check these items. And what happens is each item that you check in the sandbox, it creates an entitlements file that's part of your app package. So when your app is executed on a host, the operating system reads from the entitlements file to make a determination of what your app is allowed to do. So that's kind of how it works. So now, let's say you've got your sandboxing set up for your app. Now you want to start adding code behind the elements on your window. So like when a user clicks a button, something happens. Here, what you would do is you go back to your main storyboard and you option click. So you hold down the option button and click viewcontroller.swift, and that will bring up the window. That dark window on the right is the viewcontroller.swift code. So you've got your code next to your design window. And the reason I believe Xcode has it set up that way is so that you can easily drag and drop elements from your window over into your code. So that Xcode knows now that this variable is linked to this particular item. So in this example, in a screenshot, like holding control and dragging and dropping that text box, it created a link in the code, an IB outlet variable. And IB is just an interface binding. So that's kind of how that works there. And here's an example of code here. If you want to put code behind your app window on to have it actually capture credentials, here's an example of what that code would look like. Once the button is clicked, the string values of those two text boxes are grabbed. I used AlimoFire third-party package to allow easy URL requests. So you just grab the contents of your text boxes that you're targeting, make the URL request, set it as HTTP post, and then when you do you set up a task, and then when at the bottom where it says task.resume, that actually executes the task. Give it a second to sleep to make sure it completes the task, and then you can exit out. But something to keep in mind, depending on how you distribute the app for your red team, if you're going to plan to have it hosted where users download it through their browser or email it out as an attachment, you'll have to get your app signed and likely notarized for future versions of macOS as well because of Gatekeeper and what Gatekeeper checks for. So you have to set up your own developer account. I recommend a burner account. That way, in case it gets kicked out of the developer program, you can move on to the next one. And you can go to developer.apple.com, pay your $100 and get that set up. And here's another example of what you could do in your app code. I'm not sure if any of you guys or how many of you are familiar with AppFell by Cody Thomas. Yeah, pretty cool. It's a really cool cross-platform C2 infrastructure for framework, if you will, for Mac, which includes macOS. And so really cool project. So if you wanted to have your app initiate a connection to an AppFell server, you could add this code here. And I'll kind of step through briefly what's happening is you're creating an asynchronous thread, which is feeding in this code here where the script variable is. That is the JavaScript for automation command that you're feeding into OSA script, but you're feeding it into the class rather than the binary on the host. So it makes it a little harder to detect. So you execute that, give it a second, and then the set activation policy of accessory will hide your app from the dock at the bottom. And then the last line will actually hide your app itself. So the app is in the background connecting to AppFell, though to the user it looks like nothing's running, like it disappeared and is gone. One thing to keep in mind, app transport security for Apple will check connections from your app out to a server. So what I've learned is not to use self-signed certs because ATS will block those. But if you have a valid cert or even a Let's Encrypt cert is fine as well, where ATS will allow that outbound connection. One other thing about notarization, I did some testing where I had an app that had credential stealing like the previous slide and had AppFell code like what's here on this slide, and sent it up to Apple to be notarized. And what I found was that Apple successfully notarized it and sent it back. And then about a week later, they did some back-end processing, and then they kicked revoked the certs for that app and kicked the account I use out of the developer program. So technically, I had a week to use it, which doesn't sound like a long time, but if you get someone to execute your code and it's already running, even it doesn't really matter if they've revoked the cert because I already have my shell on I have access to the host. So just something to keep in mind. Running short on time, so I'm going to very quickly step through these examples of detection for both old, kind of what I would call the command line based post exploitation, as well as the code based, which is looking at OSA script execution, what's spawning shell environments on your host. And at the end of the day, just having good network visibility, being able to detect beaconing type activity, seeing anomalies around apps. Are they dropping other files? Are apps beaconing out? Things of that nature. One other thing I'll mention, I recommend for Blue Teams is to stay up with Jamf, which purchased Patrick Wardle's company, and he's been on the forefront of bleeding edge research for a while. I think some cool things will come out of this joining between these two for blue teams. Last, just some, here's a link to the Swift version of my Python code on my GitHub, and I have a blog post as well that goes into more detail for things that I mentioned here in the talk. And definitely check out AppFail by Cody Thomas. So again, out of time, but thank you guys for listening in, and feel free to come grab me if you have any questions.